Hello everyone, welcome back, and this is a follow-up video of our previous question, which is diagonal sum, and this is the coding part of that question. We have already discussed all the logical approaches to solve that particular question. Now we are going to do the coding part. As you can see, I have already initialized and declared a 2D array with the name of matrix and called and made a function with the name of diagonal sum and with the argument named matrix, and we'll store the returned answer in the result variable and print that particular variable. Okay, now let's move to the function and write the code for that. First we'll create a variable named sum and initialize it with value 0, that currently our sum is 0. Now we write a for loop. It will start from 0 and go to the matrix.length, and we write a nested for loop in this for loop which starts with 0 and goes for the column which is matrix.0.length. And in this we'll do first find our primary diagonal sum. Okay, for primary diagonal sum we'll check whenever if matrix of I, which is I equals j, then do one thing, add it the value to the sum variable of that indexes. Okay, plus equals matrix of I comma j, I and j. Okay, this will add up all the values which are at the point in the matrix of 1 1 0 0 2 2 3 3 4 4. Then first primary diagonal will be added. Every value of the first particular diagonal will be added up in the sum variable. Okay, in this we have already covered the middle part of an odd matrix. If we have been given a 3 cross 3 matrix, then the middle element will be covered in this. Okay, now in the else if part we do for our secondary diagonal. Okay, if I plus j, okay, equals if I plus j equals matrix dot length. Okay, whenever I plus j sum is equals to matrix dot length minus 1, that means it is our secondary diagonals element. Okay, then what we're gonna do, we add up that thing in our sum variable, sum plus equals matrix of I comma j. Okay, now what we're gonna do, we'll return it. Okay, after that thing we'll return our sum variable. Okay, that is single equals is an assignment operator and this is comparison operator. Okay, it will compare and give our result. Let's see, it should be 68, which is correct for our given matrix. So you can see this is a nested loop, and we have already discussed in our previous video, whenever there is a nested loop the complexity will become an big O of n square. So we have an optimized approach. We have already discussed that we can do it with the simple for loop. We can in the order of n we can find the solution of this question. So first comment it out this code, and we'll comment it out and write optimized one. Okay, I'll do comment this. Control K C in VS Code is a shortcut for commenting out. Okay, so make sure whenever you use, you can do this. Now for the optimized approach, we'll write a for loop, and for loop will start from 0 and goes up to matrix.length, which is correct. And for primary diagonal, what we're gonna do, whenever in the nested loop, you can see whenever in the matrix the row and column number is same, then it will be definitely our primary diagonal element. Okay, so whenever matrix, that means I and j has the same value, that means I and I is also would be the same particular index you can find on that matrix. So here our primary diagonal will sum plus equals matrix of I and I. Okay, see, this will give us the sum of primary diagonal. Now for the secondary diagonal, we need to make sure that whenever there is an odd matrix, you should always think of the middle element. If it covers again, that it will be our overlapping condition. So you should make sure that whenever we are having an odd matrix, we should aware that we do not add up again the middle element. Okay, for that we have condition which is if our ith element, okay, which is ith iterator, is not equals our jth. So for jth, we have already find out how to find jth index with the help of, if you are having n and I, which means row number and total length of that particular row. So we can find the particular j. Okay, for whenever I is not equals matrix dot length minus 1 minus I. Okay, matrix dot length minus 1 minus I is a corresponding value of I at any position of that given matrix, so I and j. Okay, so you can consider j as matrix dot length minus 1 minus I. So in this, what we're gonna do, sum plus equals matrix of I, and for j we have already known matrix dot length minus 1 minus I, which is our j basically. Okay, and this will return our sum. This is for primary and this is for secondary. Okay, now let's check it out. It should give us 68. See, it is giving us 68. So I think you can find this video helpful. Thank you.